Hi, everyone. My name is Sarah LaBelle, and I am the production manager here at Eckerson Group. It is my pleasure to welcome you to today's webinar on data integration for hybrid Azure environments. We're thrilled that you're able to join us. And as folks are trickling in, I'm going to run through a couple of housekeeping announcements and some intros. So I'm excited to announce today's speakers. We are going to be hearing from Kevin Petrie, our Vice President of Research here at Eckerson Group. And for the past 25 years, Kevin has deciphered what technology means to practitioners as an industry analyst, writer, instructor, marketer, and services leader. Kevin launched, built, and led a profitable data services team for EMC Pivotal and ran field training at the data integration software provider Attunity, which is now part of Click. A frequent public speaker and co-author of 2 books on data streaming, Kevin is also a data management instructor at eLearning Curve. Our guest today is Joseph Treadwell, who is the Solution Director at Time Extender. Joseph facilitates the technical enablement of new and potential partners. When he's not helping these partners develop data and analytics solutions with Time Extender, he's evangelizing at conferences and leading Time Extender's solution specialists around the globe. Joseph has spoken and demonstrated analytics solution at events like Microsoft Inspire, Click Connections, and various Data and Analytics Association chapter meetings. A little bit about Eckerson Group. We are a research and consulting firm that specializes in data and analytics. You've hopefully read some of our articles and reports, and we also do consulting. Before Kevin and Joseph kick it off, a little bit of housekeeping. If you have questions or comments, please use the Q&A button at the bottom of your screen, and we'll address those at the end. You can use the chat feature if you have a problem or a question for the administrator, which is me, and I'll answer you as soon as possible for those. So without further ado, let's get to it.
All right. Thanks, Sarah. Really pleased to have the opportunity to speak with everyone today and to re-engage with Joseph, who's got some great insights to share as well about what Time Extender is doing to help customers. So the topic today is the art and science of data integration for hybrid Azure environments. And I'll frame this by talking a little bit about what data integration is. As Sarah said, in my background, I was with Attunity for 5 years, which is very focused on data integration. And there are really 4 different elements to a taxonomy, if you will, for what data integration means. Broadly speaking, you're bringing different pieces of data together and you're putting it in a format that can be used for operations or very often for analytics. And we'll be focusing on analytics use cases today. There's the ingestion piece. So to ingest data means to extract it from a source. It might be a database. It might be a feed of IoT data coming off of a machine part. It could be a lot of other things. You're going to extract it from that source and you're going to load it to target. The target might be, in this case, Azure Synapse. So a data lake, an Azure-based data lake in the cloud. It could also be a data warehouse. We'll talk a little bit about how some of those constructs are merging. You're going to ingest it and extract it either in batches or in increments. And this is an important point. The historical method of extracting data in batch certainly works when you have a one-time migration. It makes sense to do incremental updates after that because then you're not repeatedly copying unchanged data. So increasingly the trend is to ongoing incremental updates. And what we're talking about ingestion is data schema, which is the structure of that data, and also metadata, the data, about what it, how it's structured, about what you can do with it and what it's being done. Transformation includes combining the data, bringing together, joining tables, joining columns, formatting data, structuring it, and cleansing it. So removing duplicates, fixing errors, removing blank columns, and that kind of thing. You also need to import or create data models. In a lot of cases, they're going to talk about how those disparate data sets should work together. The manage piece gets into the data pipelines that are performing the ingestion and the transformation. And so data pipelines are essentially workflows that help bring together the data schema, the metadata between source and target. And there's this important layer, which is managing those data pipelines. You need to design them, develop them, test them, and then deploy them and manage them on an ongoing basis, providing updates based on KPIs or other monitoring signals you have coming in. The control element is another layer on top of this, which is provisioning access to users, provisioning access to data pipeline managers, controlling versions of pipelines, orchestrating workflows that might well trigger operational actions based on analytics insights the data pipeline is enabling. And then you need to, from a compliance and governance perspective, document the environment and track lineage for compliance. So modern data integration includes these pieces and includes them in different orders. So you could have extract, transformation, and load, which is the traditional method. Streaming ETL is a new popular flavor of that, which moves data in the increments as opposed to the batches that I was talking about earlier. You could also have ELT, and that's a scenario that we'll talk about here, and Joseph will go through some of this: extract, load, and then transform on the target. You could also have new variations like ETLT, transformation in the staging area, more transformation on the next zone, or ELT, LT. So a lot of different flavors rather than getting into an alphabet soup. Suffice it to say that based on the requirements that you're trying to meet, you're going to have different orders and methods of ingesting and transforming data. We're talking here about Azure, which is a really important target for a lot of organizations. As we know, there are a number of mid-sized and large enterprises that are very focused on grown up using SQL Server data warehouses. And increasingly, they're seeing a lot of benefits on Azure because Azure provides those cloud benefits of elastic, pay by the drip resources, of decoupled storage and compute resources. And it also provides access to a lot of advanced analytical tools. So a lot of different reasons to start to move data to the cloud, and we'll talk about those. The challenge is you still need to integrate with a lot of the stuff that's on premise, and that'll be a primary theme of what we walk through today. So why do enterprises need data integration? Stepping back from Azure a little bit, there's this data democratization trend. Organizations need to make data-driven decisions or data-informed decisions, but they need to have broader contextual awareness about the factors at play when they decide when and how to launch a product, when and how to launch a marketing campaign, when and how to make a specific recommendation on a real-time basis to a customer, or when and how to halt a machine part based on signs of wear and tear. These are all examples of real-time or periodic data-driven decisions. There's also a trend within data democratization to adopt self-service analytics. So there are a lot of business-oriented users who are not PhDs in data. They're not data engineers, but they need to figure out how to consume data and might well roll up their sleeves a little bit and handle some of the preparation of data for analytics. So advanced analytics is another key trend here. There's obviously a huge trend in another area of research that I'm doing related to machine learning, which effectively is software that identifies patterns in data to help make predictions. And so there are a lot of different ways in which people are using machine learning or other types of artificial intelligence to create new insights. They need to operationalize those insights with automated action. In a lot of cases, they're using structured or semi-structured data that rows within a SQL data warehouse. The third key trend here is data modernization, which is essentially in order to meet the demands from the business for data democratization and advanced analytics, the providers of the data owners, IT needs to figure out how to do stuff more efficiently. They need to take cost out of the system, improve efficiency, enable digital transformation, and really re-architect for the cloud. So that's the superset of forces that are taking place. As we all know, when everyone or a lot of people started working from home, there was a lot more movement to the cloud. And so organizations have only accelerated the digital transformations of their businesses, and therefore the data democratization, advanced analytics, and data modernization trends that are simply driving up need for data integration. Okay, so we've got a barbell here. The data pipeline is under a lot of strain. As I said before, the data pipeline is essentially a workflow that's going to ingest and transform data between source and target. There's an explosion of supply of data, new types of data, new types of cloud-based applications, new types of IoT data, new social media streams, all kinds of ways in which you can extract digital signals from your operations and start to analyze that. But that means that you need to figure out how to handle that supply of data. Then you've got the demand. The demand is that the business people want more and more data so they can enable those data-driven decisions. New users, new applications, new devices, new use cases. In the middle are the data pipelines that are feeling a lot of strain. You have a lot of pipelines, siloed platforms, and complex processes. So this exploding supply and demand squeeze data pipelines on both sides. And so the folks that Time Extender is working to help are these enterprises with mid-size and large enterprises. Data teams have a lot of technical debt. Data engineers have a lot of data pipelines that have accumulated over time, kind of brittle, and there's not enough automation. And there's not enough flexibility to meet evolving demands as you add supply and add demand. So what we're trying to do with this webinar is help you identify strategies, best practices, and then product evaluation criteria to meet those demands and create more efficient pipelines between the supply and the demand. Okay, so what are the requirements here? You need to extract from all major sources. And so a critical component of a data integration program and tool is to support not just the new sources, but the old sources as well. Mainframe is doing great. There's a lot of mainframes still out there, and it's expected to continue to grow. So you still need to integrate with those specialized sources and figure out how to publish your data from mainframe, from other legacy systems to new targets. You need to figure out how to load all major targets. Automating repetitive scripting is something you're going to see a lot when Joseph goes through his demo. The more you can standardize the repetitive stuff, the more you can accommodate custom scripts, accommodate custom transformation in a modular way, the more you can be very flexible and agile and also not take a lot of time to create, adapt, and reuse data pipelines. That's critical in order to meet not just today's requirements, but the future. So that's going to be an important theme here. It's also critical to consider incremental replication, potentially streaming on an ongoing basis so that you're eliminating the unnecessary copies of unchanged data, that legacy batch ETL. Scaling on demand is critical. So the more you can activate new sources on the supply side, new data volumes, changing velocities, and then on the demand side, bring online new users, new use cases, and in between, scale up your consumption of the compute resources, of other replication threads, all the things that are helping bring together those exploding supply and demand. So that scaling on demand is critical. And modern data integration tools can help you eliminate a lot of the silos that plague most enterprises and improve efficiency. So what does good look like? It can be achieved. Staff productivity, data engineers can achieve more with less. They can focus on more innovative projects and not repeatedly script SQL tasks, not repeatedly enable scripts for SSIS or Azure Data Factory. Data literacy means that on the demand side, you're enabling smarter decisions. People who are more savvy about how to use data to do their jobs. IT cost reduction means that if you're not repeatedly copying stuff, if you're reusing data pipelines, reusing artifacts and adapting them more easily, you can operate more efficiently, take cost out of the system. And then cloud modernization, obviously. We all know cloud has some significant benefits, but you want to achieve it in a way that you're actually making things simpler. And so automation is a big part of that. So those are some of the things that you need to look at from a benefits perspective. Keep your eye on that in order to make sure you have your eyes on the right. The data value creation, obviously, is the desire to make sure that you're capitalizing on insights and making more decisions. So effective data integration can really drive strategic C-level priorities with the cost and top line and bottom line benefits. Okay, so use cases. There are really a few primary use cases that we can talk about here. Building a new cloud data platform is a very popular one. You might well reverse engineer or import a data model or create something new from scratch in order to phase out or complement on-premise data warehouse, say a SQL Server data warehouse. You want to replace that over time and phase in an Azure Synapse data warehouse. Migrating to a new cloud data platform is a close cousin of this. You need to take the data from your sources, you need to point them to this new target and migrate your old data and put it into the new transformation flows that are required. Machine learning is a very common way in which organizations are starting to think about consuming the data. So putting these self-teaching models into place so that you could automate preventive maintenance, you could automate a customer recommendation, you could automate fraud checks, things like that. So it's early days, but there are a lot of enterprises looking at this and looking for data integration tools and practices that can bring that structured data together, that can help you define the inputs that matter most, the machine learning features, is critical, and data engineers play a big part of that. At a larger level, another use case here is figuring out how these different data pipelines work together. How do you make those pipelines interoperate? How do you reuse and adapt them? I was saying before, and how do you make sure that you have the right workflow that triggers one action between applications? For example, if you have an application that's going to operationalize analytics output from a given pipeline. And finally, it's critical, obviously, to synchronize data across heterogeneous platforms. As I mentioned, the old stuff rarely goes away. Most analytics is going to bring in data, integrate data from more than one source. Keeping those updates on the sources synchronized to the target on an ongoing basis is critical. So these are all use cases that data engineers tackle as they think about data integration. So now if we get down to brass tacks, I can talk about what the product evaluation criteria are. What are some of the key questions that data engineers and their management teams need to address as they think about ways to automate, to improve the efficiency and the agility of their data pipelines? First one, and it's really critical, is what level of technical knowledge does this product require? Now, you don't want to bring in someone off the street to build your data pipelines, but you also don't want to continually rely on one or two deep individuals who know where all the skeletons are buried for the custom code, who know how to script everything within SSIS or Azure Data Factory. You really want to enable more general data engineers who are savvy, but not necessarily script savvy. The more you can empower them, the more you can bring online new data sources and new data targets in order to meet business needs. So look for automation and look for intuitive prompts that will pre-populate fields that will recommend things to you. And also look for ways to support the inevitable custom work in a more modular fashion. So you could take a new machine learning model, drop it into a workflow or a pipeline very easily. There are a lot of different ways in which you want to reduce the scripting that would be required for SSIS or Azure Data Factory. The sources and target support is critical. And the only thing I'd add to it is that try to support stuff you'll need in the future too. The more you can standardize on one or a few data integration tools that support whatever you think you'll need next year or the following year, the better, because the data integration platform that you have really should be a versatile tool, and it should be somewhat trivial to add and drop sources and targets in the future, rather than having to go back to square one next year and buy a new data integration tool. Performance is critical, and so obviously go through the necessary checks with proof of concept or otherwise to meet your throughput and your latency, SLAs, and so forth. And then, the more you can choose something that has a lot of cloud affinity, the better. Are you making use of multi-threading, of multi-node capabilities? Is there a consumption model that works for your budget, cloud-based? So these are all ways in which, if you start with the beginning and we look at business requirements, the why, this really gets to the how from a tool perspective. And what I can do now is hand over to Joseph, who can go the next level and show you what Time Extender is doing in these areas.
Thanks so much, Kevin. That was a lot. I'm not sure if we'll be able to handle all of that, but let's see, right? So I'm going to go ahead and share my screen and tell you all a little bit about Time Extender and hopefully how it can help you address all of the needs that Kevin just mentioned earlier. Now, a great way to think about Time Extender, it's a platform, it's a data management platform, but an even better way to think about it, I think, is to think about it as an operating system, right? Take, for example, you have Windows. Your Windows operating system has a lot of settings, and now with OneDrive, you have all your files, but you might get a new laptop tomorrow. Well, your operating system, your settings, and your files, given that they're all stored in the cloud, can come with you. So the hardware can change, but how you interact with that hardware stays the same. And that is a fantastic way to think about Time Extender, using the power of software, of automation to eliminate or reduce tedious scripting, and then manage the development, the maintenance, and the documentation of a modern data estate. Now, with Time Extender, we actually manage the data estate in 3 distinct layers. And I'm going to talk a little bit about those 3 layers right now. The first layer is what we call the operational data exchange. And this is where we handle the area that Kevin mentioned, the ingestion part of the data management process. So ingesting that data. Embedded within our platform, it comes out of the box with over 220 different unique data providers. So you can get connected to just about any data source that's out there. That's in addition to all the more generic ones, ODBC, REST, these different generic APIs that you can connect to. Of course, automating the portion around scheduling and ingesting that data into your initial landing area. The second layer is what we call the modern data warehouse. And this is where the transformation happens. So taking these various different distinct data sources and bringing them together to create a cohesive set of data so you can begin to gain insights across all of your different data sources. Even though those sources may not be similar, bringing them together and aligning them is an essential piece if you're going to start gaining insights from that data. And then the third layer is, of course, delivering the data out to the users. Now, while a single organization is going to have a lot of data and in their data warehouse, a distinct set or group of users might only require a small portion of that. So the data marts or the semantic models allow us to deliver relevant data sets out to the users to allow them to explore something a little bit more relevant to find insights that much faster. And then, of course, across all of these three different layers, we handle and manage the metadata of all of this. And this allows us to do things like managed execution, making intelligent decisions on how to refresh your data faster, providing things like data lineage and documentation. So you're never wondering, where is my data? Who has access to it? Where is it coming from? These things can be found out very, very quickly from within the platform. Now, talking a little about the hybrid approach to data management and modernization. So with Time Extender being an operating system, it's able to abstract the business logic. You're applying all this business logic, which data sources to bring in, how they come together, and abstracting that away from the hardware that's underneath it. And this allows you to move from and choose the hardware that you want and that works best for your organization. Let's take, for example, this scenario where many organizations are still operating on premise right now using SQL Server. And that's perfectly okay. Time Extender supports that. It has been building data warehouses on SQL Server for almost 15 years now. But of course, you want to look towards the future. You want to modernize. You want to be able to scale to address this explosion of data sources and the explosion of needs that Kevin was mentioning earlier. And how do you do that? Well, of course, these cloud-based platforms can allow this. Now, by abstracting the business logic, Time Extender is going to allow you to choose the platforms that you want, whether that's in the cloud or on-prem. You can land your data in the cloud, bring that back on-prem, push it back up into the cloud, really choose what's going to work best for your organization at any point in time. If you find that you scale to a platform and maybe it's a little bit too expensive and you're willing to scale back down, you get to choose the platform that works best for your organization, for your needs, and for your business. Another great thing about that modernization and moving to the cloud is it's going to give you access to a lot of other modern platforms that are available. Let's take, for example, this is one of our popular reference architectures with Time Extender. You can use Azure Data Factory to ingest that data, have it, manage it in a data lake, and then use Azure Synapse Analytics to do that. Of course, Time Extender is going to manage all of the scripting and management of all of that data across there. And then you can leverage the other powerful tools available in Azure, such as Azure Machine Learning, to perform some data science, to do some machine learning on that data, push it back into the Time Extender environment, and Time Extender can continue to orchestrate that data and that information. Okay, so giving you a little overview there. Now, what I'd like to do is I'd like to step into a story. This is a story of how an organization manages their data with Time Extender and how the features available allow them to be very agile with the system, make updates quickly, and of course, choose the platforms that work best for them. Now, this organization is currently analyzing their purchasing data, as you can see here. So they're analyzing their purchasing data. They have a warehouse here in the USA, and they're analyzing all their purchasing reports. But they recently opened another warehouse in Europe, and they want to start analyzing the data available and the purchases happening in Europe as well. So they need to connect to a new data source. They need to integrate that into their data warehouse, and then, of course, update their reports. In addition to that, the organization also wants to convert what you're seeing here in USD, in the US dollar. They want to also show their reports in euros as well, because they do have some executives sitting out in Europe. So they want to be able to show that. So how do we do that quickly using Time Extender? So let's jump into the Time Extender platform, and I'll give you an overview. So first of all, on the left side, you can see the Solution Explorer, and this is the overall overview of our Time Extender environment. In here, you can see the Operational Data Exchange, which I do have open in this tab right here. We can note the Modern Data Warehouse, which I have open in this middle tab here, and I'll manage it there. And then we have our different semantic models. We have a sales model, purchasing model, again, different data for different groups of users. And you can see my purchasing model is currently open here. And this is the main source for that dashboard that I showed you just a second ago. Now, the first thing that we need to do, again, let's focus on this conversion from USD into euros. How are we going to do that? Well, of course, we're going to need to know what is the current exchange rate so we can convert that information over. Now, to get the current exchange rate, what we can do is we can connect to a web service and bring that data into our operational data exchange. So I'm going to add a data source here, and this is going to walk me through a wizard that's going to allow me to add this data source very, very quickly. I'm going to call this data source exchange rates. Click next. And here I'm able to select from over the 220 different providers that we do have available. We can scroll through the list, just kind of browse and see what we have, or we can simply search in the filter box here, and let's see if anything is coming up for exchange rates. So I do have this open exchange rates. I'm going to use the latest version 2021 here, open exchange rates. So this is a web service. You can go to openexchangerates.org and you can create a free account, and it'll provide you with this information using this API. So they give you an app ID. I happen to have this app ID copied into my clipboard here, and I'm going to paste that app ID right in. So by providing that app ID, this allows you to authenticate and connect to your account on Open Exchange Rates. So we can test that connection and see how quickly we can get connected to this cloud service. Okay, great. So we're connected there. I'll click next, and I have the ability to select which tables I want to bring in to my operational data exchange. We'll go ahead and search through the tables that are available in this API, and I'll just select, in my case, the first 3 available tables. I can click, I want to include those tables, of course, here, and then click next. I'm also going to add a transfer task, and the transfer task is going to allow me to transfer on demand or schedule future transfers of this data. So I can click add here, and then let's say every day at 3 a.m., I want to bring in the latest exchange rates for this data source. So I'm going to select every day here at 3 a.m., and I'll go ahead and click OK. So not only have I connected to a web service, I've now scheduled that web service. So I've operationalized the ingestion of that data into my data lake all within just a few seconds. So I've synchronized that. And the next thing, of course, I want to do is hit transfer. So I'm going to execute this transfer task, which is going to move that data, connect to that web service, extract that data, and land that into my Azure data lake, which is the storage that I'm currently using here. Okay, so it brought the data in. That's great. The next thing I want to do is I want to bring that data from my lake into my data warehouse. Now, if you're familiar with these technologies, you might know that this process can be very challenging. How do you take data that's actually stored in a text file or a Parquet file and then move that and put that into a relational database table? That can be a challenging process. But luckily with Time Extender, again, having that automation allows you to manage the system and manage your data that much easier. So I'm going to open the operational data exchange data catalog here, and I can search for tables, and I can search through the different data sources that I have. So we have this new data source, exchange rates, And I can simply browse through that data source. Now, I just want to bring in the latest exchange rate. So I can simply drag and drop and bring this right into the data warehouse. So having that automation allows me to move data between these different platforms that much faster. And what you'll notice here is right now, my data warehouse, or my modern data warehouse, is actually using on-prem SQL. So I'm actually leveraging on-prem SQL Server right now, and we'll show you in just a minute how we can leverage the cloud platforms as well. So I'm bringing it from an Azure data lake into my on-prem SQL Server very quickly here. And I need to, of course, transform and integrate that data together. So I need to take the value field, bring this into my purchase transactions, and we can do some conversion. So I'll drag value and drop that onto purchase transactions, and I get to define a join. We'll say here the currency is equal to the value of the euro. So this will join those two tables together and bring in the value field into my purchase transactions table. This is going to allow me to take my order amount in USD and then perform a transformation on that. Of course, I want to keep my USD field. So I'm going to clone this one and we'll call it order amount euro. Here I have order quantity multiplied by unit price. Let me edit this transformation. And then I can multiply this by that value field. Now, if you notice, as I typed there, we did have the IntelliSense that pulled that up. I was able to select that field automatically. And once I did that, it actually brought in this parameter. So what this parameter is doing is it's taking a portion of my script and it's linking it with an object in the project. Now, what does that mean exactly? So oftentimes in a data warehouse scenario or any type of data scenario, you'll go in, you might find the need to change the name of a field. Well, of course, doing that is going to break any downstream transformations you might have that's using that field. And so you can have a lot of challenges with that. So one of the nice things, and I'm going to actually close this tab right here so we can see a little bit more. We have order quantity multiplied by unit price multiplied by the value. Let's say one day somebody comes along and says, well, actually, this is the value of the euro. So I want to rename that to specify that. Of course, that's going to break my downstream transformation. I can simply hit enter here in Time Extender, and it's going to update those transformations for me automatically. And it's going to automatically translate any of those transformations that I've written into the object name. So this is going to allow you to maintain that data warehouse and that data estate that much easier down the road, simplifying and reducing the time required to maintain these massive pipelines and structures. So we did some transformations here. Now, if you remember earlier, we had this additional warehouse also in Europe. Now, if we look in our ODX, we do see somebody's actually was nice enough to add this data source for me. They're bringing in the Europe data using Azure Data Factory. So that's great. So I can simply just, again, browse through my data lake here and find the data that I need. We'll see here there's actually quite a bit going on in my data lake. So let's narrow it down. I want to search for anything with the word purchase in it. So we do have the data I'm looking for. We have purchase order detail. Now, what am I able to do here? I do have an existing table. I want to integrate the two. What I can do is simply drag and drop onto this existing table, and Time Extender will attempt to synchronize these two tables together to line up those fields to get as close of a match as possible. We see here, this is the data movement pane, all of the existing fields that were already mapped. You can see that they're all bold. And now with this new table I just dragged in, it was able to map a good majority of those fields in there automatically. Of course, not all of them. We're not going to have identical tables here. So I can simply drag and drop fields like modified date onto last edited when, and then continue on with my day. So we've made our transformations here in the modern data warehouse. Now, the last step that I want to do is I need to update my purchasing model to reflect those changes and bring in the new data. So of course, we have our order amount in euro. I want to bring that into my purchasing table here. We'll click OK. And then I can add a measure. I actually want to hide that field and create it as a measure instead. We'll call this order amount in EUR. And here we have, we can define the aggregation type, sum. This is going to be a decimal. that's a currency. And we can even specify the currency in here so it'll show up properly in our reports. We'll use the German euro for this one. Go ahead and click OK. Now we've made all the changes we need to in the interface. Now, the next piece that we need to do is we need to deploy and execute the project. Now, this is going to do a number of different things for us. First of all, this is going to create a new version of my project, which will allow me to roll back at any time, undoing any harmful changes I may have found throughout. So let's say maybe I made a mistake. Of course, I can roll back very, very quickly from those changes. So here I'm going to put that I added exchange rates, and I'll hit save. Now, what this is going to do is this is going to look through, compare my project with the underlying databases, the data lake, the SQL database, and the analysis services. And this is going to deploy and execute everything. So it's going to create and write the scripts that it needs to update tables, alter tables, create tables, and then it's going to execute that data. So this is going to pull data from all of my data sources, land that in the data lake, and then bring it into the data warehouse, perform those transformations I just wrote, and then execute that data in the analysis services model as well. And you can see it's doing this all in 5 simultaneous concurrent threads, right? So this is going to allow Time Extender to automatically organize these executions to make them as efficient as possible. So by organizing them in threads, and because Time Extender understands the dependencies, you'll find that day after day, it actually will get smarter and faster because it's understanding your data better, and it's reorganizing these threads to ensure the fastest overall execution of your data. Now that we've finished our execution, we can go back to our dashboard and we can see the data that we've added here. Go ahead and hit refresh, and we can see here we brought in our European data. We can see these blue stacked bar chart here, and that's coming from our European data source. And then let's go ahead and bring in this additional measure that I added as well. Go ahead and click add that in, and now we can see the order amount there in euros. So we're able to integrate 3 different data sources all within just a few minutes here and make these changes quickly. Now we can bring these reports, bring this new insight out to our users, again, just within a matter of minutes. But of course, now the questions come, right? How did you get to this data? Where is it coming from? It doesn't match my reports. So to answer these questions, we can use Time Extender's integrated data lineage feature. So here we can right click on that measure that I created. We can go to visualization and click on data lineage. Now, if I expand that, we can see here that I can trace this data all the way back to the source. We can see here in the data warehouse, I'm performing a transformation, multiplying 3 fields together, and then again, tracing this data, these 2 to their individual data sources, and this to that open exchange rates data source. Okay, that's great. But of course, now we have more and more data coming in. It turns out our on-prem SQL Server isn't quite good enough to keep up with the demand. So what we can do in Time Extender, and because this is an abstraction layer, it's an operating system, right? The hardware, you can actually swap it out as needed. So we can actually go here to my data warehouse. We can switch from on-prem SQL and go straight to Azure Synapse. We'll click OK. This will define, recognize all those changes, and then I can simply deploy and execute again to apply those changes, move that data over to Azure Synapse, and then benefit from the scalability and all of the power that is available, of course, in the cloud. So being able to move between on-prem into the cloud, of course, is made very seamless and very easy by Time Extender. So that's all I have for you today. I believe now it's time to transition into Q&A.
Sarah, do we have some questions?
We do. It looks like we've got a few from our audience here. So our first question is, what are the most common use cases that Time Extender addresses?
Great question. Yeah, number of different use cases. Of course, I would say our most common use case is building a new data estate, right? Organization has gotten to the point where they realize that data is essential to the running of their business. And so they want to be able to manage that data efficiently, easily, and start from zero and be able to build up that data estate as quickly as possible. One of the most common use cases for time extender. Another use case is to modernize an existing data estate. Now, you saw how we're able to move from on-prem into the cloud so quickly. We also have a lot of features integrated that allows you to look an existing data warehouse and then bring in some of those transformations, some of that existing logic, bring that into time extender, modify that, bring that fully into time extender, and then, of course, then bring that up into the cloud as well. So building a new data estate, modernizing an existing data estate. One of the third use cases that we see is preparing data for machine learning and AI. Now, of course, in the industry right now, it's very popular. Everybody wants to get in on this AI trend. What is this? What is it? What insights can this provide for my organization? And so they hire a few data scientists or a consulting organization to come in and take a look. Now, what ends up happening is these data scientists end up spending 80 to 90% of their time just gathering the data and bringing it to a place where you can start performing machine learning on that data, because there's a lot of data cleansing that needs to happen prior to the start of a data scientist's job. And so by using Time Extender, we're able to bring that data in to normalize that data in a single platform, in a single area, and then you can begin to do machine learning on top of that data. So those would be the three most common use cases for Time Extender.
Wonderful. Our next question is a bit more technical. So this person says, I understand that Microsoft Azure supports confidential computing through either of the two following options. 1, encrypting the entire virtual machine at runtime. 2, using VMs based on Intel SGX. And their two-part question is, first, does that first option, encrypting the entire virtual machine at runtime, use quantum-proof cryptography? And then the second option, using VMs based on Intel SGX, relies on a process of attestation done by Intel, so the end user should trust Intel. However, if Intel and a cloud service provider decide together to gain unauthorized access to the end user data or code, they can do that. Is this correct?
That is a great question. I don't believe I am equipped enough to answer that, unfortunately. Kevin, what about you?
Unfortunately, I don't have a good answer to it either. It's a great question, and I think folks at Azure are probably best equipped to answer it. But I appreciate getting stumped, so I think we welcome stuff like that.
So find perhaps a less technical question. How about best practices for migrating a SQL Server to Azure Synapse?
That's a fantastic question. Best practices. Well, one of the challenges with moving to a technology like Azure Synapse is a lot of people think that it's just like a beefier version of SQL Server. And in a lot of ways it is, but in a lot of ways it's actually very different. So if you do have a manually, written store procedures, right, in SQL Server, you have all of these pieces. You can't simply just take all those stored procedures and put them into Azure Synapse and then assume that that's going to work. There's a very different way of working with data because of how Azure Synapse manages and stores that data. It needs to be handled differently. So the scripting that's done actually needs to be changed. And that's one of the things that Time Extender does so well, because it recognizes what platform you're pushing to. It's automatically transforming those scripts to ensure best practice for the environment that you're in. So I would say that, of course, do your research, ensure that you understand the technology well and how to build these different processes, these different pipelines in that technology before you take that step, because there's a lot more to it than just taking your stored procedures and moving them into the cloud. Of course, a great option is using automation to do that, right? Looking at these scripts and transforming them. And of course, that's one way that I would recommend as a best practice. Any
Wonderful. So I think we've got one more so far. So if any of the audience members have other questions they'd like to add, I can...
I hate to talk over you.
Oh, go ahead.
I'd like to add one more conceptual point with the migration best practices, which is not to do it as as a one-time project for a couple of reasons. One is that you might well need to have a one-time transfer of data from source to target. In all likelihood, there'll need to be ongoing synchronization with certain data sources and so that's one thing to keep in mind. The more you can standardize on an automated platform for doing that, the more you can support ongoing needs after the bulk load of the initial migration. And then the other point would be that the more you standardize and take sort of a formal approach rather than doing shortcuts to enable a one-time migration, you can be prepared for the next similar type of project. Reusing artifacts, reusing pipelines can help you in the future too. And so those are the reasons that you want to look at migration as something that in some form will need to be repeated in the future.
Great. The last question I currently have in the queue is, how does Time Extender support custom transformation requirements?
Great question. Yeah, fantastic. I can actually show that here on screen. So when we do have custom transformations that we need to make, everything that I showed in the demo was our no code approach, right? So we saw a lot of drag and drop, not really any code. But some of the beauty that is happening behind the scenes is simply taking these scripts that are well-known best practice and handing those scripts over to the underlying database platform to be processed. So you can simply go into here, for example, edit this transformation, and you can write any type of SQL logic that is supported by that underlying platform. So if you're on SQL Server, really it's any scripting language that is supported by SQL Server. If you're in Azure Synapse, it's going to be anything supported by Synapse. So any type of custom code that you need to do, custom scenario, right? It is an automation platform, but every customer, every organization is so unique. You can't automate every single scenario. So we allow for plenty of areas for this customization to happen, whether that's in a single field transformation that you saw here, whether that's in writing custom view. So if we go in here, we can actually see we've written custom views here, or if it's just fully writing custom script and stored procedures. You can, of course, do that within the platform and manage that through our managed execution. You still benefit from things like data lineage and this managed execution because it's tied into the object dependencies that's built into Time Extender. Hope that answers your question.
Wonderful. And I don't see any more questions in the Q&A or lurking in the chat, so I think we may wrap up early today.
Fantastic. Thanks, everyone. Thank you, Joseph, for the insights, and Sarah for steering us through this. Really enjoyed the discussion, and I hope this was helpful for everyone.
Thanks so much, Kevin.
Okay. Thank you.
All right. Have a great day, everyone.